So in the last video, we spent a fair amount of time detailing the difference in the different addressing modes for ARM v7. They're clever and complicated, as is most stuff in ARM v7. So I'm going to review them again quickly, and then we're going to give some examples. There are three options for loading and storing in ARM v7. The one is you specify an address in a register, and you're done. We call that register addressing. The second is pre-indexing. You specify an address in a register, you modify that address by some value, and then they use that as the effective address. You change the pointer before you use it. And then there are some choices about whether you save that new value. And then the third option is post-indexing, where the register contains the effective address, but then you modify it after you use it by some value. Those are the three options. So let's do some examples of that. Oh, by the way, this is the format. You're either LDR, load register, or STR, store register. And again, they can be conditional, so you can choose to do that on some flag. And then you can choose whether or not you are moving a byte or the full word. Those are your options. So you can LDR EQB or STR, what else? STR GTB or something like that, right? Those are your options. Then you specify the register in the register file you're dealing with. Normally we call this the destination register, but don't forget, for storing, this is actually the source. You're moving information from the register file, RD, into memory. Still call it the destination register for more confusion. And then the load store address, which is specified in this way. These are the 5 different ways to specify the load store address. So let's have some examples. Auto-indexing. This is where you are modifying the value of the pointer as you go. We call this auto-indexing. And there are 2 options, auto-indexing pre-indexed and auto-indexing post-indexed. Auto-indexing pre-indexed means we're going to offset the pointer by some new value and then use it. Auto-indexing post-indexed means we're going to use the pointer and then we're going to modify it by some value. And these are only relevant for auto-indexed access. This is where you are using a single instruction to access an element in memory and then changing that pointer to another element. Working your way, indexing your way down an array or something through a data structure automatically. This is one of the great efficiencies of ARM v7 is that a single instruction can access a pointer or access an element in an array and also move the pointer to the next element in the array in a single instruction. Very cool, very efficient, very clever, very complicated. So pre-indexing looks like this, for example, load register RD, and then the effective address is enclosed within those parentheses, within those brackets, right? That's how you know what it is. The pointer, RN, modified by the offset, whatever that is, and then updated or not based on the presence or absence of that exclamation mark. And then post-indexed is the register, which is the destination. The effective address is in RN, and then it's offset after. Okay? You modify the value after access, and again, that implies that you're writing it back. So you don't need the exclamation mark here for post-indexed. If you're modifying it after you use it, that means you're changing it. Here, if you use it before you modify it, you may or may not want to change it. But if you're modifying it after you use it, you're changing it. All right, so what do these look like? Auto-indexing, pre-indexed, and post-indexed addressing. Here are some examples, right? So again, be careful when you're using R15, the program counter, right? If the base register is R15, it may already have been incremented. So don't worry too much about this. But basically the idea is it gets very complicated very quickly when the pointer that you're accessing is actually the program counter, and you're looking at information back and forth between that. So this example here, if we're loading into R1, R2 plus 2 and writing it back, then we're actually doing 2 things. This is register transfer notation. We're transferring registers back and forth, so we use RTN, register transfer notation, to specify what we're actually doing. We do 2 things here. R1, the memory at R1, is going to get the value specified by the memory at R2 plus 2. So we get R2, we add 2, we use that as an address, and we use that to load memory, and we put that into the register, R1. Also, we're going to take R2 plus 2 and put that into R2. We're updating R2 because the exclamation mark tells us to update R2. So that's two things happening. Okay? Post-indexed does the same, but does it slightly differently. First of all, it's going to modify R4 by 2, but do that after the memory access, down here. Before that, we're actually going to access R4. So R4 is the address. That's specified by these double brackets. R4 is the address of the memory we're interested in. We load R4, we put it into R3. Then, after that, we're going to update R4 by adding 2 to it so that it's in the right place for the next memory access. So that's the difference between auto-indexing, pre-indexed, and post-indexed. Do some thinking about it. Pay attention to it. These pictures are meant to show you the different examples of what's actually happening in each of these cases. They may or may not be useful. Let's skip that stuff. Then the last thing we can do is what we call a block transfer. So this is going to be loading a whole bunch of stuff. This is a batch load store or a block load store. This is really, really cool. This is for stack access. So if, for example, before a subroutine, we want to store a bunch of registers on the stack. Or after a subroutine, we want to pull a bunch of registers from the stack. This is what block transfer is for. So this is a batch load store or a block load store, BLS. So what we do is in the same way we specify 1, 0, which is our load stores. Then we have a few other flags which are similar. Whoops. Pre or post index, just like before. Up, down, just like before. And now we have SP, which is whether or not we're storing the program status register, which we'll talk about a little bit later. Essentially, when you do a subroutine, you can, if you want, have a special separate status register. And you may or may not want to store or restore that. That's the SP flag. And then W is whether you're writing back the base pointer. That's the same. LS, load store, that's the same. And then instead of specifying a register and an offset, what we do is we specify an address, RN, and then we take 50 or 16 bits. Each bit is a 1 or a 0, depending on whether we want to store or not store that register. So that's a one-to-one list of every register in our register file, whether we're going to take that whole register as a stack and put them in memory, or whether we're going to take that whole register and stack and retrieve it from memory. So you can use this as a context switch, right? You can just batch load in a whole set of new registers, blop, as a single instruction. It's really, really cool. Useful operation. So this looks like, this is a next thing. So that's block data transfer. And that's the load store instructions. So now we've got the data instructions, data processing, multiply, and swap. We've got the load and store instructions, which include load store and block load store. And now we've only got one other kind of instruction, which is our program flow instructions, our choices, our branches, our jumps, our software interrupts. So we'll do those next.